Is it possible to get more than one solution when you solve a linear system? That's what we're going to take a look at in this video, and let's see what we can find out. So we're going to solve some systems. I'm going to assume you know how to solve your systems by now. So here we have two equations, and we want to solve the system. So we can do it a lot of ways. We can use substitution, we can use graphing, so on and so forth. Let's go ahead and use substitution since it's kind of set up for that. Let's go ahead and insert this equation into this value for y. And we get 1/2 x minus 3 equals 1/2 x plus 2. All right, and now we're just going to solve this equation because the y's have gone away because we substituted. So let's go ahead and subtract. And when we subtract our 1/2 x from both sides, we get -3 on the left equals 2. And does -3 equal 2? No, that's not a true solution. That's not true. So something happened here. Did we do our arithmetic wrong maybe? Well, we can check. No, we just substituted there. We rewrote it right, copied everything correct, and the 1/2s do subtract away. But we get something that's not possible. Well, let's graph it and see if we can figure out what's going on here. So if we come over to our graph here and we plot, we graph the first one. First one here has a y-intercept of 2, slope of 1/2. So let's graph that, y-intercept of 2. Rise of 1, run of 2. Okay. So we get a slope of 1/2, and we can go down the other way too if we want. Got plenty of lines there. So let's draw the line. Whoa, that's a fat line. There's a much better line. Okay. And let's graph the second line. We got a y-intercept of -3 and a slope of 1/2. So let's graph that one there. Get a different color here. Slope of y-intercept of -3 and slope of 1/2. Rise of 1, run of 2. Rise of 1, run of 2, so on and so forth. And let's graph that line there. There we go. And what do you notice about these two lines? Well, hopefully we notice they're parallel. So we got two parallel lines. And remember, when we're solving a system, we're looking for the point where they cross. Well, these points, these two lines never cross. So this has no solution. So it is possible for a system of linear equations to have no solution. Let's look at another one. Here we got a couple equations. We've got 4x plus 6y equals 12, and we've got y equals -2/3 x plus 3. Want to solve the system? Well, this is kind of set up for substitution also. So let's go ahead and substitute here. Let's put this in place of y and see what we get. So again, we're going to substitute this value here for y. So we take our first equation, and in place of y, we're going to write 2/3 x plus 3. -2/3 x, that is. Okay. And so let's go ahead and distribute here and see what we end up with. So we have 4x plus 6 times -2/3. Well, 6 times 3, or divided by 3 here. 6 divided by 3 is 2. Times -2 would be 4. So this whole thing here is going to be -4x. And then we have 6 times 3, and that's obviously 18. And, all right. Well, again, these cancel out, and we get 18 equals 12. So these lines are parallel lines, so we say no solution again. Let's tweak this one a little bit here and try something similar but a little different. How about this system here? Everything's the same except we let's change that 3 to a 2, and let's see what happens here. Well, we're going to substitute the same kind of way that we did a minute ago here. So let's no solution there. So we're going to substitute, and we'll get something like this. Put the -2/3 x plus 2 in for the y. And then we distribute. And this time we're going to get, again, negative 4x plus 12 equals 12. Those cancel. And 12 equals 12. Is that a true statement that 12 equals 12? Sure is. Well, what's going on with this situation? Let's check. Let's try to graph it here. So to graph the first one here, we're going to find the intercepts. When x is 0, we'll just kind of cover this up here, and y will be 2. When x is 0, y is 2, because 6 times 2 is 12. So 0, 2 is our y-intercept. Now when y is 0, x is 3. If you cover up the y term, that could become 0, and we're left with 4x equals 12, so x will be 3. Okay, and I can find a few more. I see the slope is negative, going down 2 right through, down 2 right 3. There's more points there if you want. And let's graph those points, or the line that is. Looks like that. Now let's graph this equation. Well, this line, which let me graph it in a different color. Let's go with green. All right, we had a y-intercept of 2. Well, there it is right there. We've got a slope of negative 2/3. So we're going to go down 2 right 3, down 2 right 3. And from this point, if we go down 2 right 3, we end up there. And then we go down 2 right 3. And we end up there, somewhere there, and there. And we notice, hey, wait a minute, that's the same line. If we go to graph this line, then let's see, let's go like this. We graph the line right on top of that red line. So it's the same line. So where do these two lines touch, the green line and the red line? Well, they touch everywhere. So there are infinitely many solutions, because the points of intersection are the solution. So infinite solutions. And the way that we state the solutions is we just write down one of the equations. 4x plus 6y equals 12. Okay, so that is the solution. That's why we have infinite solutions, because they're the same line. And if we would have looked careful, if you solve this for y, you'll actually get the same thing. All right, let's look at one more case there. Let's solve this system here. Let's use elimination here. So we'd like let's get the y terms already line up. That's great. It's all ready to go with elimination. Let's go ahead and add these equations. If we add them, we get 3x. The y's go away. And that equals 15 divided by 3. And x is 5. That was handy. Plugging that in to one of the equations doesn't matter. Let's go to the first one here. We have 5 minus 3y equals 9. We subtract 5, negative 3y equals 4 divided by negative 3, and y equals negative 4 divided by 3, which is negative 4/3. So the point is 5, negative 4/3. Okay, so we got a solution. Well, this is just normal. Looks like we have one solution. So let's go ahead and graph that just to verify that. So to verify, we're going to graph the two lines. First line here, well, we have when y is 0, x is 3. That's our x-intercept. And when y is 0, no, we said that already. When x is 0, y is 2. Okay. So that's that line there. Had it a few minutes ago. And we get the line that looks like this. Okay? And then this other one here, when y is 0, x is 9. So we have an x-intercept of 9. And when x is 0, y, that goes away, and x would have to be negative 3. So 1, 2, 3. And that's good enough there to make a line. That looks something like that. And let's check it out. Does that look like 5, negative 4/3? Negative 4/3 is a little less than 1. So we're going over 1, 2, 3, 4, 5, and down negative 1. Okay? By the way, we should be putting some numbers on our graph here for our axes. So, yeah, that looks right. We got it. Okay, so we can either have lines that intersect at one point, like we've seen before, or lines that have infinitely many solutions because they intersect all over the place, or lines that don't intersect at all. That gives us no solution. So, possible solutions to a linear system. We have one solution if the lines cross at one point. Okay? So if the lines cross at one point, we have one solution. We have no solutions if they're parallel lines. That means they never cross. Okay? Parallel lines never cross. Something like that. Okay? And when you're solving the system and you end up with something like 5 equals 6, for example, or 0 equals 3, well, those are not true. So whenever you end up with something that's not true, your answer is no solution, no real solution. So when we have infinitely many solutions, these are the same line. All right? The same line. So when you're, we have one line there, and then we've got another line that is really the same line. Okay? So we're talking about when we have something like 5 equals 5 or 0 equals 0. That's a very true statement. So when you're solving a system and you get that, or you get 0 equals 0 or something like that, okay, then that's always true. And you say that's always true, so we have infinitely many solutions. It's the same line. And the way you write your answer is you just write down one of the equations. Okay, so those are your three possibilities for solving linear systems. You'll get one of these three outcomes. And if it's one solution, you obviously state the solution. If it's no solution, you just write no solution. If it's infinitely many solutions, you write one of the equations as your solution. Good luck.